In 1965, a physicist won the Nobel Prize for mapping the interactions of light and matter. His work represents the peak of modern scientific instruments, yet his foundational view of reality was completely identical to a man standing on a Greek beach in 500 BC. One used particle accelerators and calculus. The other had no technology, no microscopes, and no calculators. He reached the same conclusion using the raw pressure of logic. To understand how they met in the middle, we must look at how we fall apart. Over roughly every 7 years, your body replaces almost every cell it owns. The physical material you were born with is mostly gone. If your physical substance is in a state of total turnover, it forces a question that predates science itself. What persists? Beneath the shifting skin and the changing opinions, what is actually real? Around 600 BC, in the port city of Miletus, a man named Thales looked at the changing world and made a radical proposal. He saw water turn to ice and water turn to steam, and concluded that every object in the universe is simply a different form of water. His student, Anaximenes, spotted a logical contradiction. If the base layer of reality is wet and cold, like water, it could never produce its opposite, fire. The two would simply destroy each other. Anaximenes proposed a different source, the boundless. He described it as an infinite, structureless potential that warps and ripples to produce specific physical objects. A third thinker, Anaximenes, argued a neutral element creates solid matter through compression and fire through expansion. He was the first to define state changes through pressure and density. These three arguments established the process of observing a physical change and assigning it a mechanical cause rather than a divine one. They had begun to look for the rules governing matter. As these ideas spread, the debate turned toward the nature of time. Heraclitus argued that stillness is an illusion. He saw the universe as a roaring fire, a force that only exists by constantly consuming, changing, and moving. But he noticed that this chaos followed a predictable path. He believed a hidden natural law, the logos, kept the fire from consuming everything at once. Then came Parmenides. He used a different logical path to declare that motion is impossible. He argued that because something cannot be created from nothing, reality cannot begin to move or change its state. It must be a single, frozen, unchanging block. His student Zeno proved this with a paradox. To walk across a room, you must first cross half the distance. Then you must cut that remaining distance in half again. Because you can divide space infinitely, you can never mathematically reach the wall. Zeno's logic was so precise, it effectively stalled the study of motion for 2,000 years, until the invention of calculus provided the tools to solve an infinite series. This created a crisis. Logic proved reality was still. Observation proved reality moved. One of them had to be a lie. Pythagoras moved the conversation away from stuff and toward relationships. He didn't care what the universe was made of. He wanted to know how it was organized. He noticed that when you divide a vibrating string by exact whole number ratios, it produces harmonious musical chords. The beauty wasn't in the string, it was in the numbers. He saw these same geometric ratios in the orbits of the stars and the patterns of nature. His conclusion was that the universe is a mathematical structure. This aligns with modern physicists like Max Tegmark, who argue that mathematics isn't just a tool we use to describe the world, it is the fabric of the world itself. Pythagoras arrived at this by listening to a lyre. The final resolution to the debate over change came from a synthesis of these ideas. Empedocles proposed that elements remain permanent and unchanging, but are rearranged by forces of attraction and repulsion. But it was Democritus who finally solved the paradox. He found a way for reality to be both frozen and moving at the same time. He deduced that the universe is made of atomos, indestructible, unchanging particles. Because the particles never change, they satisfy the logic of stillness, but because they move through a void and hook together, they create the illusion of change. When an object decays, the atoms simply break apart and reassemble into something else. In this framework, nothing is created or destroyed, it is only rearranged. Democritus defined the atomic nature of matter in 400 BC. He didn't have a particle collider, he only had the pressure of a 200-year-old argument that demanded a logical solution. To confirm the existence of these particles today, we build machines like the Large Hadron Collider. It is 17 miles of superconducting magnets to do what Democritus did with a thought experiment. We spend billions on telescopes to find the mathematical patterns Pythagoras intuited. We use these machines to verify what these men first suspected while sitting in the dirt. This brings us back to Richard Feynman. His summary of all human scientific knowledge was a single sentence: all things are made of atoms, little particles that move around in perpetual motion. These philosophers intuited the existence of an infinite ground state and the atomic nature of matter centuries before the first glass lens was polished. They proved that human thought, when applied with enough rigor, can touch the truth of the physical world. The drive to peel back the surface of reality is a human trait. It is a stubborn requirement to look at a functioning system and ask, but why? This question mapped the stars and the atoms, and next week we'll look at the man who turned that same question on the citizens of Athens until they voted to kill him.